Okay, so we're going to practice sketching polynomials based on end behavior and root behavior. So these are not absolutely perfect graphs of these polynomials, but they're a general idea of what their shape is. Okay, so again, the first thing that you should always look for is the total power of your polynomial. So the total power, if we FOILed all this out, we've got a first power, a second power, and a first power. So if you total these all out, our total power is 6. That is our degree of our polynomial. Okay. Our leading coefficient is negative because this is 1 times 1 times 1 times -3. So my leading coefficient is -3, which means that it acts like a quadratic, or the end behavior looks like a quadratic that's opening down. So even degree, negative leading coefficient, which means my end behavior on both sides is going down. My roots are at 0, +6, and -4. Okay, so again, since these are points we know the actual function hits the x-axis and they're the only place, when this function leaves, it's either going to go down or it's going to go up. Since I know the end behavior is down, I know it goes down here like this. Now, at this root, it is first power, so odd roots cross the x-axis, so it crosses the x-axis. Then it's going to go up so far, but it has to come down to this root. And again, this root is power 1, so it's odd, it's also going to cross there from this one. Now it's going to go down, it's going to do something, but then it's going to have to come back up to this root, and because this root is even, it's going to come up to this root and bounce right off of it and then go back down. Okay, so this is the general shape of my polynomial. Both of my end behaviors are going down and down, cross, cross, bounce, based on my roots. Okay, so let's look at this one. Again, each one of these powers is 1, so my degree is 3. It's odd. And my leading coefficient is +1. So basically this has the end behavior of the cubic with a positive leading coefficient, which means it's going to end up going up on this side and down on that side. Okay, now let's graph our roots. We have a root at -6 from this one. This one is -1, and this one is +4. And this one's really easy. Again, let's start on the left side, and since this one has to go down to follow the end behavior, now notice we have all odd roots. So it's going to come up here, it's going to cross that root, come back down, cross here, and then come back up and cross here. And sure enough, we end up matching with our end behavior on the other side, and our cubic function will look something like this. Okay. Again, let's start with our degree. What is the degree of this polynomial? I've got 2 plus 2, which is 4, plus 1 more, which is degree 5. So it's odd. My lead coefficient, 1 times 1 times 1. So my leading coefficient is 1. So odd with a leading coefficient of +1, which means again it's going to look like the cubic going up on this side, down on that side. Graph our roots. This root here is x equals 0, -3, and +7. Okay? So again, we're going to start on this side right here. Since it has to either go up or down, and we know our end behavior, it goes down like this. The root here is an even power, so we know it bounces. So it's going to bounce there. Then it's going to go down and come back up, and this one's also even, so it's going to bounce there. And then it's going to go down, and then it's going to come up, and since this one's odd, it's going to cross, and sure enough, we end up where we're supposed to be. Now, if I had done this, and I had gone down here, and I had bounced, and then say here I had crossed, when I came back here and crossed, if I had ended up back here knowing that I was supposed to be up here, I would have known that I made a mistake. Okay? So use your end behavior at the end to kind of double check yourself. All right, our last one. First thing we're going to check is the degree. I got 2 plus 2 plus 2, which is 6. My leading coefficient. I got 1 times negative 1, so it's negative 1. Which means I'm even with the leading coefficient of negative. So it goes down and it goes down. Okay. My 0 is at x equals 0. This one's at positive 5, and this one is at negative 5. So start on the left again. So again, following my end behavior, this side is down. Okay, so let's look at this root. Even power, so it bounces. Comes down, goes back up to this root. Even power, so it bounces. Then it goes down, and this comes back up to this root right here at positive 5, and it bounces because it has an even root. So it looks like that. So basically it comes up, bounces, comes up, bounces, comes up, bounces, and goes back down. That's how you sketch polynomials using end behavior and root behavior.